Hello, my bomb blowers and module masters, and today I am here with another Keep Talking and Nobody Explodes modded module tutorial. Today, I am here with the module Partial Derivatives. This module covers a calculus concept. That might seem very threatening, but it really is not. Taking a derivative is one of the easiest parts of calculus, and I will try to simplify it as much as I can in this video. With that out of the way, I'm going to go ahead and get started. This module requires all of the edge work on the bomb, so I'm going to go ahead and start by getting all of the edge work. Oh, we have one battery. I think I saw lit CLR. Yep. Plate parallel serial. Which was that plate? And, oh boy, plate DVI PS2 RCA RJ. The serial number is Alpha 76 Foxtrot Delta 8. With that out of the way, let's take a look at the module. So, partial derivatives consists of a big equation of three terms. Each term has an x, y, and a z value. It also has an LED, which can be one of 6 colors, and a keypad to submit numbers on. So, as the diffuser, you're going to go ahead and read out this big equation. Let's go ahead and do that. So our equation is 6x to the 4th minus 4x to the 5th, y to the 4th, minus 3x to the 3rd, y to the 2nd, and z to the 1st. So let me go over a bit about this equation. There are three terms of equation, the 6x, the 4xy, and the 3xyz. Each term has an x, a y, and a z value. You might not be able to see it, though they still exist. This is because if there is no y, z, or x value, that means that respective variable is risen to the power of 0. When I say to the power of, I mean the exponent. The exponent is the small number above each variable. If there is no exponent, the exponent is 0. If there is no exponent shown, the exponent is 1. And the number in front of the entire equation, this 6, this 4, this 3, is the coefficient. So I'm going to be using that terminology a lot. So anyway, now that we have our... No, wait a second. We need the LED color first. That is important. The LED is red. Now that we have our read, let's go ahead and take a look at the manual. The first thing we're going to do is find out what variable we need to pay attention to. We're going to do this by looking at the LED color. If the LED is a primary color, red, yellow, or blue, you can just plug it straight into the table, and that will give you your respective variable. So we have a red LED for stage 1, which means x is our variable we're going to pay attention to for this stage. If our LED was yellow, we pay attention to y. If it was blue, we're going to pay attention to z. If we had a secondary color, orange, green, or purple, we would use the variable whose color is not a component of that secondary color. If we had purple, that's red and blue, which means there is no yellow and purple, so we would use y. If we had orange, that has red and yellow in it, there is no blue and orange, so we would use z. If we had green, that has yellow and blue in it, so since there's no red, we would use x. But we have a red LED, which means we're using x. Now that we know we're going to pay attention to x, what does that mean? We're going to derive this big, scary equation to x. Now, what the heck does deriving an equation mean? What we're going to do is take the exponent and multiply the coefficient by that exponent of the specific variable. We're deriving to x, so we are paying attention to the exponent attached to the x value. If we were deriving to y, we would pay attention to the 1 attached to the y value, this 4, this 2, and if we were paying attention to z, we would pay attention to the exponent attached to the z value, which is this 1. So, we're paying attention to x. We're going to take the exponent and multiply by the coefficient. 4 times 6 is 24, and we're going to replace the coefficient with that value. We're then going to subtract the exponent that we just dealt with by 1. So 4 minus 1 is 3. And we're going to do that to all 3 of the terms. 5 times 4 is 20, and 5 minus 1 is 4. 3 times 3 is 9. 3 minus 1 is 2. This is our derived equation. That wasn't so bad. Really, when you learn how to derive an equation, this module becomes really easy. Deriving is not hard, once you know how to do it. The power rule is pretty easy, and it really is one of the easier parts of calculus. Now that we've done that, what do we do next? We're now going to find values for x, y, and z. Plug those into the equation, which will give us a number. So for stage 1, we're going to use the stage 1 row. This table has a lot of shorthand in it. A lot of the shorthand is explained here. In fact, all of it is. B is batteries, BH is battery holders, LI is indicators, UI is unlit indicators, P is ports, PB is port plates. Simple enough. And it also has SN1, SN5, SN4. This basically means the respective characters of the serial at those respective positions. So SN1 would mean the first character of the serial, which is this alpha. SN3 would mean the third character of the serial, which is the 6, not the F. SN4 is the fourth character, which is F. SN6 is the last character, which is 8. SN2 is the second, which is 7. And SN5 is the fifth, which is D. If the character is a digit, like this 8, the 7, or the 6, we would use that respective digit. And if it was a letter, we would use that letter's alphabetic position for the value. So let's check the table. Stage 1 x value is the first character of the serial, alpha, which is 1, plus the number of unlit indicators, 0. So x is 1. Next we have the fifth character of the serial, which is a delta. Delta is 4, minus the number of lit indicators, minus 1, which is 3. And finally we have the number of battery holders, 1, plus the number of port plates, 3, which is 4. Now, if you ever have a 2-digit number, you're going to take the last digit of that number. If the variable results in a 0, then that is automatically replaced with a 1. If you get a negative variable, then you add 10 to the variable until it's no longer negative. So anyway, we have our x, y, and z values, so we can go ahead and plug those into the equation. X is 1, y is 3, and z is 4. We're going to submit the last 4 digits of this number. You may say, but wait, it's negative. Does that mean anything? No, it truly doesn't. Now, say we had something like, I don't know, negative 920. Or negative 10,920, that's better. So you would say it's the last 4 digits is 0920. However, if you have a 0 at the start of your answer, you will not submit that 0. You would just submit 920. So this answer would be the same no matter how many zeros we would put here. It would always be submitting 920. So, but for this one we have negative 1920, so we're going to go ahead and submit 1920. That is correct. So we're on to stage 2. Stage 2's LED is blue, which means we're deriving to x again. Let's do that. The exponent of x is 3, times 24 is, I don't know that off the top of my head, so I'll just do this, 72. 3 minus 1 is 2. We have 4 times 20 is 80. 4 minus 1 is 3. And 2 times 9 is 18. X minus 2 minus 1 is 1. So this is our derived equation for this stage. And we're going to get new x, y, and z values. So our stage 2 x value is the third character of the serial, which is 6, minus the number of port plates, which is 3. 6 minus 3 is 3. The y value is the number of batteries, 1, plus the number of battery holders, 1, which is 2. And the sixth character of the serial, 8, minus the number of the indicators, 1, is 7. These are x, y, and z values, so we're going to plug them into the equation. X is 3, y is 2, and z is 7. We're going to submit the last 4 digits of this answer, 5424, submit, and we're done with that stage. On to the last stage. The LED is yellow, so we are once again deriving to x. Two times 72 is, I believe, 144. Let me double check. Yep. And 2 minus 1 is 1. 3 times 80 is 240. 3 minus 1 is 2. 1 times 18 is still 1. And 1 minus 1 is 0. Because we have a variable raised to 0, we can actually just go ahead and remove the variable from the equation. This is our final equation, but let's say I did something else. What if I derived to z right now? Now, you may look at this variable, this term, and see that it does not have a z variable. If you're deriving an equation, a term even, and it does not have a variable you're deriving to, you can just go ahead and remove that variable. Likewise, there's no z here, so you would, once again, just remove the variable. And then you would just multiply 1 by 18, which is still 18, and then subtract 1 from 1, which is 0, remove the z, leaving you with just this. That's just a theoretical situation, but our derived equation is this. So we're going to, one last time, get values for x, y, and z. So, stage 3x is on the indicators, 0 plus batteries, 1, which is 1. The fourth character of the serial is f, which is 6, minus the number of ports. 1, 2, 3, 4, 5, 6, 7. 6 minus 7 is negative 1. And we need to keep it positive, so you add 10 to all negative numbers. 10 plus negative 1 is 9. Finally, the second character of the serial, 7, plus the number of ports, 7, is 14. We only use the last digit of a two-digit number, which is 4. So these are our x, y, and z values for the last stage. X is 1, y is 9, and z is 4. We submit the last 4 digits of this answer. You will notice we have a leading 0, so we will ignore that 0 and just submit 328. That is a solved partial derivatives. Once you get the hang of taking derivatives, this module becomes really easy. And it really doesn't take that long to get good at taking derivatives. You just got to make sure that you know what the mechanics of the module are. What the LED colors mean, how to derive specific situations. And one of the most common errors I see is if you're deriving to a term that is not in the equation. You just remove that term of the equation. And you will also need to keep track of the signs. In this equation, when we derive to the z, we just remove this term. But that negative was still there. Once again, we derive to z here, we remove the term. The negative is still there. Just because we derive a term does not mean that that sign does not go away. Actually, I think if we did derive this as z, it would be 0 minus 0 minus this. Which I'm not sure if that is a negative. Let me check. Oh, it's still negative. Okay. Can't do that math in my head. So I'm going to go ahead and do one more partial derivatives. we're going to start by getting the edge work. 2 batteries and 1 holder. A lit SND. Plate with RCA RJ. Plate with DVI PS2. And plate with RJ and DVI. The serial number is Alpha Echo 6 Sierra November 2. So I'm actually going to read this equation off a little differently. You can use this method, or you could use the method I used previously, but all I'm going to read off now is the numbers. The coefficient, the x exponent, the y exponent, and the z exponent. So for this equation, it would be 2453 plus 6043 plus 1511. So I started off with the coefficient for all 3 of the terms. There's a 2 here, a 6 here, and if there's not a visible one here, if there is no visible coefficient, the coefficient of the term is 1. And then I started with the x exponent. 4, there is no x variable here, which means x is risen to the power of 0. And then 5. Next I write off the y exponent, which is 5, 4, and there is no visible exponent, which means y is risen to the power of 1. And then I wrote the z exponent, 3, 3. Again, no visible exponent, so it is risen to the power of 1. So I'm just going to go ahead and reformat this equation to make it easier to copy-paste into that calculator I was using earlier. The calculator I'm actually using is Sam Funds. You may know him from other modules in this game. If I can get permission from him to post the calculator in the description of this video, then I will probably do that. I also really don't know how to do it right this second, so I'm trying to get him to tell me. So if I get that sorted out, you'll find this in the description of the video. Let me just double check this is correct, because I really have not done it like this before. It is, and the LED is blue. Alright, so what variable do we derive to? The LED is blue, it's stage 1, so we derive to z. Let's go ahead and derive to z. 3 times 2 is 6. 3 minus 1 is 2. We use the exponent attached to the z this time because we are deriving to z. 3 times 6 is 18. 3 minus 1 is 2. 1 times 1 is still 1. 1 minus 1 is 0. Z to the power of 0 is 1, which means we can remove this. Basically, if we get a variable to the power of 0, we're basically multiplying the coefficient with this value, with this value, with this value. Anything to the power of 0 is 1, so we're basically just multiplying by 1. So this is our derived equation for stage 1. We're going to go ahead and get our x, y, and z values, and plug them in, and submit our answer to the module. So we have serial number 1, 1, plus unlit indicators, 0, which is 1. The 5th character of the serial, November, is 14, minus the number of lit indicators, 1, which is 13. The last digit of 13 is 3. And finally, battery holders, 1, plus port plates, 3 is 4. So we're going to plug these into their equation. X is 1, Y is 3, and Z is 4. We're submitting the last 4 digits of this answer, 6659. That is correct. Stage 2 LED color is red. Delete these because we're going to get new ones for this stage. Now we're deriving to the red variable, which is Y. Stage 2, red, Y. So we have 5 times 6 is 30. 5 minus 1 is 4. 4 times 18, don't know off the top of my head, 72. 4 minus 1 is 3. 1 times 1 is still 1. And 1 minus 1 is 0. Because it's risen to 0, we can just remove the term. And this is our final equation for stage 2. I have a feeling I did something wrong there, so let me just double check right quick. That's good, yep. Okay. So, we're going to get new x, y, and z values. Serial number digit 3 is a 6 minus port plates 3. 6 minus 3 is 3. Batteries 2 plus battery holders 1 is 3. And finally, serial number 6 is 2 minus the number of the indicators is 1. 2 minus 1 is 1. Plug these in for x, y, and z. X is 3. Y is 3. And z is 1. We're going to submit 9017. We do have a 0 here, but it's not a leading 0, so we do include it in our submission. So 9017 is good. And our final stage LED is green. This is a secondary color, so we are going to derive to the variable not in green. Greens consist of yellow and blue, which does not include red, so we're going to derive based on red, which is z. 2 times 30 is 60. 2 minus 1 is 1. 2 times 72 is 144. 2 minus 1 is 1. And you notice we don't have a z here, so we can just go ahead and remove this term, because it ends up being 1. Basically, you're deriving 1, which is 0. If you ever derive a constant, it's 0. That's a mathematical explanation in layman's terms, but that's not important. All you need to know is that if you're deriving a variable and it's not there, you just yoink it out of the equation. So this is our final equation for the last stage, and we're going to get x, y, and z values. On the indicators, 0 plus batteries, 2 is 2. Well, that did not go as planned. The fourth character of the serial is Sierra, which is 19, minus ports, which is 1, 2, 3, 4, 5, 6, is 13, which is just 3. And the second digit of the serial, 5, plus the number of ports, 6, is 11, which is just 1. If you ever have a letter, and it's a two-digit letter, you can go ahead and just do the substitute for the last digit. Sierra is usually 19, but you can just go ahead and use 9. November is 14, you can just go ahead and use 4. Either way, you're going to get the same number. I'm going to double check this because I think I did something wrong. This is known with the indicators, plus 2 is 2. 9 minus 6 is 3, and 5 plus 6 is 11. Yep, okay, this is right. Let's plug them in one last time. X is 2, Y is 3, and Z is 1. Submit the last 4 digits. And that is another solved partial derivatives. That's going to conclude my tutorial for today. I hope you learned something from this module, and this skill will actually be pretty helpful if you ever decide to pursue calculus in college. Thank you for watching, and as always, have a nice